lesson today is very specific about the kind of triangle that you can use the formulas in. Before we start, we need to go back and revisit what an altitude of a triangle is. And an altitude of a triangle is a segment that connects one vertex across to the opposite side in such a way that it hits at a right angle. So connecting one vertex perpendicular to the opposite side. So in this first picture here, BD is an altitude. Notice it falls inside of the triangle. If by chance you happen to have a triangle that has an obtuse angle, the altitude will fall on the outside of it. So as far as definition of an altitude, it has to be drawn from one vertex to the opposite side, hitting at a perpendicular. Specifically today, we are talking about when an altitude is drawn into a right triangle. So in this particular picture, the right triangle that they're referring to is triangle ACB. It's the big triangle. And the altitude being drawn in is the altitude that goes from C to D. What ends up happening in this particular case is that you end up having three right triangles. The big triangle is a right triangle. And then the triangle over on the left, triangle ACD, is a right triangle, and then clearly the triangle on the right is a right triangle again also. So there's three right triangles. All three right triangles are similar to each other. And when we have this particular situation where all three triangles are right triangles, we can use one of these three formulas to solve for missing sides or angles. So our first formula deals with the altitude, which we'll talk about. The second one deals with leg one. And then the third one deals with leg two. And it's not helpful to know what's going on with those formulas until you know what the names of the sides in the picture are. So this becomes a very important part. So we already know that that's the altitude that goes from C to D. In a right triangle, meaning the big right triangle, this is the hypotenuse. And the other two sides in the right triangle are called the legs. So just to differentiate between them, we'll call these leg one and leg two. Now there's two other segments that don't have names yet, and you can use the B in the formulas to either refer to bottom or base. So this part here is a bottom, and this part here is a bottom. I'm going to call this bottom 1 because it's on the same side as leg 1, and this bottom 2 because it's on the same side as leg 2. And when we're working on a question that involves this kind of triangle setup with an altitude, what's going to happen is only one of the three sides that come up off the hypotenuse are going to be used. And I'll give you an example of what I mean. So in this particular picture with our hypotenuse on the bottom, there are 1, 2, 3 sides that I consider upsides that come up off of the hypotenuse. And those are the ones that you see used in these formulas. It's either the altitude, leg 1, or leg 2 that we're going to be using. So in question number 1, when they tell me that they want me to find AB, AB is what I'm looking for. I'm going to put an X on it. And I can see that the upside that they're using in that particular question is this upside right here, which we have called leg 2. So then I scan through my formulas, and I find the formula that uses leg 2, which is hypotenuse over leg 2 equals leg 2 over base 2 or bottom 2, whatever you want to call it, and I substitute in the information that I need. So in this particular case, the hypotenuse is X. Leg 2 is obviously the 10, and we use that 10 twice in the proportion. And then bottom 2 is going to be this 4 that's here. It's the bottom or part of the hypotenuse that's closest to leg 2. And this becomes the formula that I have to cross multiply and solve. So when I go through and cross multiply this, I end up with 4x equals 100. 25. So when you're doing this, having these formulas memorized is essential to being able to set up your proportion and go through and solve. So for question number 2, again, I know that the whole bottom part is my hypotenuse. There's 3 sides that come up off the hypotenuse. This one that's being used is the altitude. As I check my formulas up above, the formula that uses the altitude is this one. So I'm going to have base 1 over the altitude equals the altitude over base 2. Please notice that the upside, whatever one's coming up off the hypotenuse, is used twice. When I substitute my information in, I have x over 12, base 1 over altitude, equals altitude over base 2. I'm going to cross multiply and solve. And this is one of those questions that turns out to be quadratic, which means you need to get it set equal to 0. And then you can factor. So you're essentially looking for 2 numbers that multiply to 144 and add or subtract to give you that 7. So I'm going to use 16 and 9. This is plus, this is minus. I make my t-chart. So I have x plus 16 equals 0, x minus 9 equals 0. Here I get negative 16. Here I get positive 9. Clearly, because we're talking about the side length, this has to be rejected, and my value for x turns out to be 9. For question 3, notice that there's 2 upsides that we're dealing with. For this particular question, I'm only going to focus on y as being our upside. Notice that this is leg 1, this is bottom 1, and if I use my formula that uses leg 1, I have to have hypotenuse and bottom 1. This is one of the places where you want to make sure you're paying very close attention, because when you start to substitute in, you have to make sure you're catching the whole hypotenuse across from this right angle, and this whole hypotenuse is 30. So when I put that in here, 30, base 1 is 6, and the other 2 are leg 1 that I'm looking for, and then I can cross multiply. So x squared equals 180. I square root both sides. I get plus or minus the square root of 180. We know that we're only going to take the positive one. Negative 1 has to be rejected. And to break up 180, I'm going to use 36 and 5. So my answer is 6 radical 5. This is one of the reasons why we did those radicals at the beginning of the unit. Sometimes what happens is they turn the triangle to make it look a little different, but you have to, in your mind, sort of rotate it so it fits our form. And our form is the right angle up here at the top, and then an altitude drawn in to hit at a right angle here and here. So this is x, this is 5, and this is 6. In this particular case, this is our leg 2, this is our bottom 2, or base 2, and our whole hypotenuse is x plus 5. So when I look at that formula, I'm going to be particular about how I substitute things in. So this is going to be x plus 5 over 6 equals 6 over x. And again, when I cross multiply, I end up with something quadratic. So x plus 9, x minus 4. So x equals negative 9, and x equals positive 4. Can't have a negative length, so clearly this one turns out to be rejected. Our final answer for x is going to be 4. Be careful, because sometimes you have to take that 4 and substitute back in. Make sure you're answering the question that they've put in front. The last question that I want to work on today is question number 6. In question 6, this is the right angle, meaning that this whole thing is your hypotenuse. The upside that we're using is this. It's the one that's drawn to the hypotenuse. Some of you may wish to turn this around so your 30 is on the bottom. Here's your right angle. Here's your altitude. And this is x plus 4. Now, when you go through and set this up from either of them, notice we're using the altitude. So when I set this up, my altitude goes twice in here. And I have two bottom parts. One is 6 and one is 24. The part that goes from here to here, 30 minus 6, 24. So when I go through and I cross multiply here, please keep in mind that you need to FOIL that. It's x plus 4 squared equals 144. So x squared plus 8x plus 16 equals 144. And then you'll get it equal to 0. So when I factor this, I have x and x. And my numbers that I'm going to use are going to be 8 and 16. This is plus, this is minus. Make my t-chart. X is 8 and x equals negative 16. This is the reject because it's negative. Sometimes you can keep both answers. In this case, we have to reject that. So you cannot do these questions if you don't know the names of the sides and if you don't know the formulas. So there's a little bit of memorizing that comes to these, but all in all, they're a very easy question